Okay, so now class, we will discuss on the ion product constant for water. So remember, do not be overwhelmed ha, nga daghan kayo og terms sa constants. Just remember nga these constants are all equilibrium constants. So it's K, these are all K, sorry. Okay, so these are all K equals the concentration of products over reactants. Okay? It's pareho ra gid na silang tanan. Ang difference ra is that gigaan lang jud nila og specific term ang kada constant depende sa unsa na siya nga equilibrium. So in the case of water, we call it as the special name is the ion product constant for water, or this is the symbol. Okay? So aqueous solutions contain small concentrations of hydronium and hydroxide ions as a result of the reaction of this reaction. Okay? So some books class would use this equation. It's just 1 mole of water to form hydrogen ion and hydroxide ion. Okay, so that is still correct. And in this module, we will interchange, we will use H plus or H3O plus. And it's still valid to say kanang inane H5O2 plus OH minus. Okay? So, it's still valid to say that. Kanang, it means nga, ang imong H plus is surrounded by, it's surrounded by H2O. Okay? Like, it could be, this is not bonded man. This is not bonded. Okay? This is just kanang interaction lang nila ba? Okay? This is not a real bond. Okay? Kanang gisurround lang siya og two ka water molecule. Okay? That's the property of water. So that means let's just take a look at this equation, kini nga equation. That means nga ang equilibrium constant ana is this. Kw is equal to H3O plus times OH over H2O squared. Okay? But then, as we know, water man is liquid, so that will be equal to 1. So, makancel siya. So, the Kw, or the ion product constant of water, is now this. Okay? So, the ion product constant is just a special name. So, let's try to solve this. Calculate the hydronium and hydroxide ion concentrations of pure water at 25 and 100 degrees. So, in this case, OH and the hydroxide and hydronium are formed only from the dissociation of water because we only have pure water, right? So, their concentrations must be equal. Kaya you only have water man. So, ang imong H3O, imong hydronium, comes from water alone, and imong hydroxide comes from water alone because water ragod ang nasa imuhang container, di ba? That means we can just substitute this. So since OH is equal to H3O man, so we can just say H3O squared, or this is also equal to OH squared, and this is equal to KW. Okay? Kaya di ba KW is equal to H3O OH minus, di ba? And then H3O is, since from this kining nga relationship, H3O is equal to OH man. So we can say KW is equal to H3O plus. I-change na nato ang OH to H3O plus. So it's still H3O plus. Or we can say KW is equal to OH minus times OH minus. Diba? Okay, it's all based on this relationship because we only have pure water in our flask. Okay, so solving for KW, it's just the square root of KW. Now, at 25 degrees Celsius, ang Kw for water is 1 times 10 to the minus 14. This value is taken from the appendix of the book. So, given dyan siya. Ang imuha ra gyud is if you know unsa ang need nga pangitaon nga constant nga given nga naa ra sa appendix, okay? So then you can solve for the concentration of H3O and OH, which is 1 times 10 to the minus 7, and also from at 100 degrees Celsius, this is also given in a table but not in the appendix of your module. I'm not sure if it went up to 100 degrees Celsius. And so it's the same method. Ang nakalahira is ang value sa iming Kw kay, di ba, as I've said, ang K will change at different temperature. Okay? Pero constant ra siya at that temperature sa kana nga equation. Sa kana nga reaction. Okay? Pero at different temperature, mubari na siya gamay. Okay? Okay, so the next type of equilibrium constant is the solubility product constant. So, from the table that I've showed earlier from the previous video, there are so many types of equilibrium constants, diba? And we've already discussed ion product constant for water, and now we have the solubility product constant. And in here we will only discuss the constants which we will mostly encounter in the future nga mga topics. Okay, so solubility product constants is mostly applicable for the type of equilibrium involved in salts. So, in dissolution of salts. So, most but not all sparingly soluble salts are essentially completely dissociated in saturated aqueous solution. Okay? So, for example, you have an excess barium iodate equilibrated with water. Now, that barium iodate, when that is dissolved in water, the dissociation process is described by this equation. So, in solution, ang kining imong solid nga barium iodate, it actually dissociates into barium ions and iodate ions. So, and then you balance the equation, of course. And so, when this system reaches equilibrium, then we can have the equilibrium constant expression, which is this, diba? That's still K products all over reactants, diba? And that's raised to the power to their stoichiometric coefficients. Okay, now since barium iodate is a solid, then that means this will be equal to 1. So we are left with this solubility product constant expression. Okay, so if you forget nga ang solubility product constant is just katong sa products ra siya, if you forget about that, then you just start with this one and then cancel the denominator. Okay, so don't forget nga ang source ani nilang tanan is this formula. Okay, tanang equilibrium constants. Okay, so the special term for the solubility product constant is this KSP. I mean, the symbol for solubility product constant is KSP, okay? So, let's try to answer this. What mass in grams of barium iodate, the molar mass is 487 grams per mole, can be dissolved in 500 ml of water at 25 degrees Celsius? Okay, so, from the appendix, we know nga ang solubility product constant or the KSP value of barium iodate is 1.57 times 10 to the minus 9. Okay? Now, the equilibrium between the solid and its ions in solution is described by this equation. Okay? So, meaning, ang KSP niya is equal to this, di ba? And we know nga ang KSP from the appendix nga mao ni siya, di ba? So, now we can solve for barium ions and iodate ions. How do we solve that? We also use this, ha? Katong nga for every 1 barium, you have 2 iodate ions. Okay? So, it's very important to remember nga kanang gamiton dyan na nimo ang stoichiometric coefficients. Alright? So, the molar solubility of barium iodate is equal to the concentration of barium 2+, di ba? Kay there's 1 mole of barium man is formed of barium iodide that dissolves, and this is also equal to 2 moles. I mean, this is also equal to kanang concentration of iodate over 2. Kay duha man kabuk ang iodate nimo, di ba? Kasabot mo ani class, ang mo dissolve nga barium iodate, for every 1 barium iodate nga mo dissolve, 1 mole of barium iodate nga mo dissolve, makaproduce siya og usa ka barium og duha ka iodate. It's from this balance equation, which means ang solubility sa barium iodate is equal to the concentration of barium 2+, or this is also equal to the concentration of IO3 over 2. Kay duha man kabuk ang imong iodate, di ba? So, since 2 moles of iodate are produced for each mole of barium, the iodate concentration is twice the barium ion concentration. Di ba? Mura na nagkatong gilet X na to ganiha. Okay? Katong let X sa ICE nga table. Okay? So, substituting this equation into the equilibrium constant expression, so now, since naataani nga relationship, we can substitute iodate for barium or barium for iodate, di ba? And we know nga ang KSP is equal to barium 2+ times IO3 raised to the power of 2, di ba? So that means we can substitute barium with IO3 over 2, or we can substitute iodate with 2 times barium. Okay? And that is what we're doing here. So now, using algebra, just basic math, it's now equal to 1.57 times 10 to the minus 9. Okay? So, meaning the concentration of barium is equal to 7.32 times 10 to the minus 4 molar. Okay? And that is the solubility of barium iodate in terms of barium. Okay? So now, to compute the number of millimoles of barium iodate dissolved in 500 ml of solution, so we use the solubility or the concentration of barium. Diba? So since we have 7.32 times 10 to the minus 4, ang gipangutana niya to compute the millimoles of barium. Remember nga, ang kini nga concentration class is the concentration nga na-dissolve in solution. So this is not, dili ni ang total nga barium nga nasa imong beaker. This is just the dissolved nga barium. Mao na ang gipasabot sa solubility product constant, sa molar solubility. Okay? So, that means sa imong solution, ang katong na-dissolve, you have 7.32 times 10 to the minus 4 millimoles per ml, or that's still molarity, di ba? It's moles per liter. This is equal to millimoles per ml. Gipunan ra ni mog milli, di ba? Okay, that's times 1,000 man ang tanan. Okay? 1,000 over 1,000. So makancel ra na siya. Okay? So that's 7.32 times 10 to the minus 4 millimoles per ml. Okay? So, you can cancel, you multiply that with 500 ml, kay dissolved in 500 ml solution man. So, Now you can compute here the moles of barium, and you're given the molar mass of barium, which is um 487 grams. Okay, this one. Okay, so the mass of barium iodate dissolved in solution in the 500 ml solution is 0.178 grams. Okay. If you have any clarifications, just tell me kay para I can make another kanang example or okay. So now from the previous video, we only discussed about the solubility of a salt or solubility of something kung katura ang naa sa solution, di ba? So, natay water, gidissolve na to ang barium iodate ngadto, a salt like such as barium iodate ngadto, and then that's it. Mao ra to, di ba? So, we ang solubility product constant nga naa sa appendix, makita ra nato in an appendix kay we can kay magamit nato to compute for the solubility of that salt. So, kung pila ang na-dissolve nga salt sa solution. Okay? So what if natay common ion nga makadisturb sa equilibrium? Okay? So now this is what we call as the common ion effect. And this is a mass action effect nga ma-predict ra from Le Chatelier's principle. So let's demonstrate the effect of common ion in this example. So calculate the molar solubility of barium iodate in a solution that is 0.2 molar in barium nitrate. Okay, so here you are asked for the molar solubility of barium iodate. Diba? So sa imuhang beaker or sa imuhang flask, kini nga flask nana na siya 0.2 molar nga barium nitrate. Diba? And you are asked sa molar solubility, so gisagulan pag nimo og barium iodate. And you are asked kung pila ang solubility sa barium iodate. So pila man ang barium iodate nga ma-dissolve ani nga solution kung ang kini nga solution nana siya sulod daan nga barium nitrate. So obvious kay diri nga ang common ion is ang barium, di ba? Okay. So since you're asked for the molar solubility of barium iodate, let's start with the equation sa barium iodate, which we already observed from the previous video actually. So we have barium iodate, di ba? This is solid. And this will dissociate in solution to barium 2 plus and 2 iodate ions. Okay? So ang K ana niya, ang KSP should be barium 2 plus and iodate. Iodate minus squared. Okay? Now, from Le Chatelier's principle, if this is our equilibrium, okay, so in equilibrium na ni siya, kini nga solution. So, kung nana na siya sa equilibrium, but we disturb it by adding this barium, kining 0.2 molar nga barium, atong gi-add ana. Le Chatelier's principle predicts nga ang solubility ang equilibrium will shift to the reverse or to the left side, so to form more of the reactants. Diba? That means ang effect sa 0.02 molar nga barium nitrate will suppress the solubility of barium iodate even more. So from the value of the KSP of barium iodate katong sa appendix nga, what's the K again? From the appendix, the value was 1.57 times 10 to the minus 9. Okay, so the value was the value of K for barium iodate is 1.57 times 10 to the minus 9. So if you notice, that's to the negative 9, which means that 0.0000456 7 8 9. Okay, that's that value ang solubility product constant sa sodium iodate. And that's equal to products over reactants, di ba? Ang K. So that means from the value of KSP itself, we can say nga dili kaayo mo dissolve ang barium iodate. Gamay ra kaayo ang iyang molar solubility. Di ba? So, if ingon ana na gani kagamay ang solubility sa barium iodate, and then giadan pa jud nato ang og lain nga barium from barium nitrate, which based on Le Chatelier's principle will shift the equilibrium to the left to form more reactants. Mas musamot pag siya kagamay ang iyang solubility, iyang molar solubility. Di ba? So, let's take a quantitative nga expression based lang sa Le Chatelier's nga prediction, if ni coincide ba siya sa prediction ni Le Chatelier. Okay? So, in this case, ang molar solubility will not be equal to barium 2+ nga atong gisolve sa previous example, because in this case naa na tay laing barium gikan sa barium nitrate, which is also a source of barium ions kay naa man siya sa same man sila nga solution. So this is the solution, di ba? So, and for your info class, all nitrates are soluble, which means that barium nitrate is soluble in water. So, ma-dissolve yun na siya sa tubig. Okay? So, there are two sources of barium ions. Okay? So, barium nitrate and barium iodate. So, we already have that equation because we are asked for the molar solubility of barium iodate. So, kana nga equation ang atong i-focus. And the barium nitrate here is, ang barium ani is the component that disturbs that equilibrium. Nitrate is just a spectator ion. Okay? So, we know, however, nga ang solubility sa barium, di ba? Dili man ta makakuan nga ang barium 2+ is equal to ang solubility kay dili equal sa concentration sa barium 2+, kay naa man tay laing source of barium. But from the balance equation, we know nga naay relationship ang barium og iodate, which is ang 1 barium 2+, duha ka book iodate ang ma-form. So that means ang molar solubility sa imong barium iodate is equal to 1/2 of the iodate. Diba? Pareho atong ganiha. It's basically IO3/2. Diba? So, in this case, na naman tayo duha ka source of barium ions. Okay? Now, the contribution from the nitrate is 0.02 molar. Okay? And for that iodate, mao ni siya ang sa iodate. Okay? So, ang imong concentration sa barium 2+ will now be equal to 0.02 molar nga gikan sa barium nitrate. Gikan ni siya sa barium nitrate and 1/2 IO3 barium and 1/2 IO3 minus, which is the relationship of this one. Kini nga relationship kay we know nga 1 barium 2+ is equal to ang concentration sa imong barium 2+ is equal to IO3/2. Di ba? From the balance equation. This is consistent man kay this is from the balance equation. Okay? So by substituting these quantities, so from KSP, we know nga ang KSP is equal to Ba barium 2+ times the iodate squared. Di ba? So, ang concentration sa imong barium is this one, 0.02. So, mao ni siya. Okay? Mao ni ang barium. And then, this one is the iodate. Okay? So, mao na ang sa iodate. Diba? And this is equal to KSP. So, mao na ang KSP man. Diba? Sa barium iodate. which we know from the appendix. Okay? So, now you have one unknown. You just need to compute for the concentration of IO3. Now, if you use the calculator, you can just directly input this equation and solve for X. Diba? And then you find the concentration of IO3. But, for, if kanang you're not using a calculator, for example, if an exam does, won't allow you to use a calculator, you have to simplify this because, you have to simplify this para masayon ang pag-solve because this one is a cubic equation kay ang IO3 diri squared na gudaan, so squared na to, di ba? Quadratic na siya. And then i-multiply pag hindi mo siya og laing IO3, so that makes it a cubic equation. So, we want to make an assumption to simplify the algebra, okay? So, we can see nga ang small numerical value sa KSP, see, it's to the power of -9. As I've said, it's 0.000000157, di ba? That's the value of KSP. So, from that value, we can say nga ang concentration sa imong barium or sa imong iodate, see, this is the KSP equation. Ang concentration ani og ani kung i-multiply pagud na nimo niya ang gawas kay 1.57 times 10 to the minus 9. That means gagmay jud kaayo ni nga values, di ba? As compared to 0.02. Di ba? So, we can say nga pwede na nato i-neglect kana nga value, di ba? The concentration of barium 2+ nga gikan sa barium iodate can be neglected because it's very small as compared to 0.02. This is just to simplify the algebra. Okay? Therefore, it seems reasonable, okay? So, it seems reasonable to assume that 0.02 is large with respect to 1/2 IO3. Okay? So therefore, we can simplify this equation and remove this term, di ba? So then, the concentration of barium will now be 0.02 plus 1/2 IO3. Okay? And since we remove IO3, this will be approximately 0.02 molar ang concentration sa barium, di ba? So, we can now solve for the concentration of IO3 using the quadratic equation. That's okay. So the quadratic equation is equal to katong negative plus minus, negative b is it right? Negative b quadratic x equal to plus minus b squared of negative b plus I forgot. Okay, so you can now use the quadratic equation, which I can't remember the formula. So here now the concentration of iodate was found to be 2.8 times 10 to the minus 4. Okay, and then we solve for the solubility of barium iodate, which is in here, diba? Molar solubility of barium iodate, this one, which is 1/2 IO3, then we can solve. We found nga molar solubility of barium iodate is equal to 1.4 times 10 to the minus 4. And if we compare this result with solubility of barium iodate in just pure water, so, nawa yung molar solubility diri ha, kung naa siya barium is 1.4 times 10 to the minus 4. But when we solve this with when we compare this with the molar solubility katong pure water ganiha, we found nga ang molar solubility is 7.32, di ba? 7.32 times 10 to the minus 4. And that's a big difference. Oh, that's 1.4 and 7. Okay, so um, indeed, the Le Chatelier's principle was kanang able to predict the equilibrium shift when an equilibrium system was disturbed. Okay?